Hey everybody, this is Dave Cooper, and we are at MODLOGIQ in New Holland, PA, right? New Holland. I couldn't believe all the Amish and Mennonites on the way out here and the horses. It's really a fabulous place to be. So what are we doing at MODLOGIQ? Well, not too long ago, we did a set with Axis Construction in Long Island, and that was probably one of the most well-run jobs that I've been in on a long time. And I thought it was really important for us to come out here and see exactly what you guys are doing and how you're becoming so precise with what you're doing. So with that said, everybody, we are live on 3 locations, LinkedIn, YouTube, and Facebook. Thanks for joining us today. We are on location at MODLOGIQ. Please hit that like and share button as soon as you can. We apologize for the noise, but hey, people are working and that's a good thing. Standing with me is Randy, who's in charge of all the fabrication here. And then we also have Casey, who is the pre-construction manager. So we're going to start with Randy. All right, so Randy, why don't you tell us a little bit about what's going on behind us here?
Okay, well, what we have going on behind us is we're starting frame construction of our modules. We get in all of our steel cut to length. We bring it into our jig here. We fabricate it according to the drawings. It's tacked together, moved into a finished section where our welders go back through. They weld everything together, then moves on to the next phase of construction where we start to make a 3D module out of it.
Yeah.
In short, make something like a Lego block, for lack of a better term.
Sure. So we were talking, and all of this material is pre-cut already from the fabricator of the steel. Correct. It comes to your location as raw steel. Then they set it, you can see I'm raising it behind me here. They actually lay it out on the jig and weld it all together and check all the measurements, get it super square, because this is the most important part of the entire project, correct?
That's correct. That's correct. This is the steel skeleton of the building.
Right. So you got the most stress of anybody, I think.
Sometimes, yes.
Yeah, right. So once it's all together here, then the next phase is, you were telling me, it goes off to painting, correct?
Correct. It gets painted then. We put on a primer paint or whatever the specifications require per job. And then it'll come in and start to get the next process, which is a decking process.
Right. So what's really cool about this whole thing is the way this is actually happening, because you guys are really going to see, we're building this whole thing on site here before it even goes to the customer's job site, which is absolutely really cool. So all right, so that happens, this goes to paint, then it comes back in. How does everything get moved from one spot to another? Because this is pretty heavy steel.
We load it on carriers and move it either with a jockey truck or a forklift. We move it into another section.
Yeah. And
we offload it with forklifts, paint it, load it back up, bring it in here, offload it with our cranes. Right. Our overhead cranes.
So yeah, I mean, we'll show you those overhead cranes are 30. I'm looking at it because I can't remember, 30-ton crane lifts. So, Casey, tell us a little bit about what your role is here.
So my role is pre-construction manager. I work on the front end with the sales team. I work through the scope of work for the client and the GC on site to make sure they understand what we're doing in the plant and what needs to be done on site. We want to eliminate any scope gaps or overlap. So there's a full process through design and engineering that we work together on.
Right. And yeah, we're going to actually meet one of the architects that was part of this project in the design. Is that accurate?
Right, yeah. Bill Barlow, our in-house architect.
Yeah, so we'll meet Bill, and we've been talking how important it is to have architects on the jobs now to really give us the aesthetics and the looks that we're going for. So, all right, so we're at the fabrication process. Why don't we walk down and take a look at how this all starts ballooning, right? Because we're gonna get the corners and the roof up here is what we're doing, right? So David, why don't we walk down here? But why don't you show them the size of that crane up there while we're walking over? I mean, we got everything here. So we got angle brackets, we got the corner brackets, right?
Yep.
Lifting lugs. What David's showing you in front of us is one of the carriers. You're seeing actually the corrugated steel for the concrete floors that'll be poured. Right? Galvanized, I'm assuming?
That's correct.
Yep. Good. And then we also have some of the carriers here. So in front of us, as we're walking, you guys can see that these are the painted floor framing systems that came in from when they were welding at the last section we were at. Accurate?
That's correct. Floors
right.
and roof frame.
Good, good. Well, let's walk by David here, and we'll come over here. I think I see Bill, the architect, standing up here. So, David, I want to actually show this real quick. Casey, tell us what we have going on here.
So this is the roof frame for one unit and the floor frame for the same unit. So these frames will go get set on the mock foundation, the floor frame will, and then we'll take HSS columns and weld them to the floor frame, and then take the roof section and set it on top of those HSS columns to make a 3D structure.
Right, right. Right, which is really what we're seeing behind us here. David, can you show that? And why don't we walk up here? Bill, come on over here with us. All right. All right, so here, why don't you come on this side? We got so many people, it's just easier to do the hand mic today. So, Bill, tell us what your role is in this whole process.
We look at the initial drawings presented to us by the architect, and then we take that initial design and we look at how we can split that up into various modular units. Okay. Fortunately, in this project in particular, the architect took a proactive approach from day one that it would be a modular building, so it makes our job a lot easier.
Right.
So as we begin the process of creating the modular units, we look at how the steel could be laid out, how it could be generated into individual mod units, and each modular unit is its own structural component. It's a free, alone, standalone structure.
Right.
So as we lift each individual box up, it basically is its own individual building. And then as those individual buildings come together, they ultimately become the total building.
Right. Well, yeah, I mean, that's exactly it. And Casey, you can walk us through a little bit of this. But so those frames are moved over here with the lift above or with a carrier, set on a foundation, right, a cribbing site foundation with the point loads accurate and where everything needs to go.
That's correct.
And then what we have is actually the framing here, and then we have the roof system on this one, because this is a one-story piece of this building. Is that accurate?
That is correct. Yeah, this is a one-story piece of a building that has a one-story section and a two-story section.
Right. And that two-story section we're going to show everybody outside in just a minute. So, Bill, I think it's very interesting you said that. One of the big things that we talk about is DFMA, Design for Manufacturer Assembly, architects getting involved in our space and really understanding the modular component of it.
That's great.
And how important is it, being that you're on the mod side already, to work with somebody up front when they're designing?
It's really part of the educational process. When I came on board to MODLOGIQ 5 years ago, it was an education to me also. So it's very important that we teach and show them what is involved with the modular process.
Right. Yeah, I mean, for sure. Are you seeing, both of you, because you're on the front lines here as well, are you seeing more architects and more designers and more, I guess, general contractors that are doing these large projects coming into the space, right?
Yes, yeah, we're seeing a lot more people going towards the off-site construction method just due to labor shortages and cost of labor.
Right, right. Well, that's really it. And how has labor been for you guys here?
We do pretty well with keeping our regular staff, so we're able to support the projects that we have.
Yeah.
Yeah.
Yeah. I love it. I love it. All right, so here's what a lot of people can't see, David. I don't know if you'll be able to show this, but we're already standing on how many inches of concrete?
3 inches of concrete.
3 inches of concrete already poured in place. This whole unit's, you know, in theory, the way it's put together, exactly how it's going to be put together in the field, and then it's going to come apart. But how do you pour concrete and then take it apart?
So what we have installed here is we have installed a pour stop. Some of it's metal pour stop, others wood pour stop, and that allows the units to come apart once we are finished constructing them.
Yeah, yeah. I mean, I absolutely love it. I mean, you're absolutely right. The greatest thing about this is with traditional modular construction, you can end up with uneven floors and what have you. I mean, this is smooth as I can't say it on camera, but it's smooth. It really is smooth.
That's why you see pairs of columns, because this column belongs to this mod unit, this post belongs to that mod unit. Double beams side by side.
Right.
So like I said, this particular modular unit is its own freestanding, structurally sound component.
Right. So So yes, exactly right. So this modular unit right here, everyone, all the way to that end to this end is one unit. You can tell this is the mate line here, right? This is the two adjoining sides. This is how you can tell. And I mean, it's perfectly lined up. And in the way these are structured, this is a school. Is that accurate?
That is correct.
All right, so this is going to be a school and classrooms, I'm assuming. I mean, look at the size of this. How many square feet is just this section, do you know?
I believe about 8,000 square feet.
Yeah. 8,000 square feet. Overall project size?
68,000 square feet of modular, 98,000 square foot total building size.
Wow, so 68,000 square feet of just the modular units themselves.
And this actually being a one-story piece, I don't know if you notice in the profile, the steel is actually sloping. So we can slope the steel to provide drainage for the roof.
Got it. So this steel is actually sloping so you can have the rain runoff go to one direction, whatever is predetermined by the civil and site engineer. Yeah.
And this structure, this mod itself, actually butts up to a fire-rated assembly wall to split the 2-story and the 1-story.
Okay.
This will all be 1 hour fire sprayed structure on this mod here to separate the two buildings.
So it will be. So it'll be a firewall separation.
Right.
Not on the structure, but between the structures.
That's correct.
Right, okay.
And the other thing my department gets involved with is when we create the documents, the construction drawings, we use a building information modeling program,
Right.
which is all three-dimensional. Also, the architectural firm and the MEP firms also use that same type of BIM modeling program, so we can look at clash detection. So the entire building is designed and modeled as a digital model before we start construction.
Perfect. So you're using BIM to bring all this together so you can get the accuracy like you did on the Good Samaritan Hospital project. I mean, those MEPs were perfectly lined up.
That's correct. Yes.
Right. How long have you guys been using a 3D modeling BIM software?
I'm guessing they were using it when I came on board, so I would say probably a total of 7 years.
Yeah, 7 years. So, listen, I think this is absolutely awesome. So, this unit's now going to stay here. Is that right, Casey? And the finished work will begin inside here?
That is correct. We'll start framing the walls, doing the exterior sheathing. It turns into essentially a conventional site once the modules are formed and the concrete's poured.
Got it. So we'll be able to see a little bit of that outside because they started doing the conventional framing on the interior walls and what have you. But everything's going to happen from this point out. So if we're talking about this structure, I'm sure there has been, there's got to be chaseways, maybe not in the single story, but on the double story. How are we running the mechanicals and how do they get laid out?
Above the ceilings, some items are below the floor, but that would be in a crawl space and they'd be connected at the job site. But as we go out there, you'll see various openings from the roof down through the floor.
Got it.
Again, that's all designed in conjunction and in concert with the engineers.
Right. How accurate do you guys find the BIM modeling software to be when it comes down to actually building this on site?
It's fantastic.
Yeah.
I mean, you really couldn't do it well without it because there's so many items that have to work together that they're not conflicting with each other, and we would much rather get those problems solved in the office versus out in the plant. Sure.
Well, I actually love it, and I think I'm going to take a look here. Let's see, guys. We have people tuning. Look, we got a lot of people. Hey, we got John Borgiorno tuning in to us today. I always get his name wrong, so I have to say it right every time. Hey, John. We got Daniel Small. Let's get our modular on. John Borgiorno says, where is the incredibly handsome Jim Gabriel? Well, he's hiding back there somewhere. I think he's doing business with somebody, which he should be doing. Jerry McCahey from Integra says, nice work, guys. Anthony Goudet, I had toured the facility with Jim a few weeks ago. Very cool. So you get to see it twice. All right, Jennifer, DFMA is part of the process. Let me see, I got to blow it up here. With designers and architects early in the construction process is a win. 100% accurate. Danny Small says, very cool to see another steel modular manufacturer. What is MODLOGIQ's rationale for going with steel versus wood?
So our model is based around steel. We do majority of steel structures. It helps with fire ratings, helps with transportability, and it helps the build together process that we can top pick all these modules, and our tolerances are lower.
Yep.
And we're also faced a lot of times with multiple larger spans that you could not achieve with wood structures.
Right. Sure, absolutely.
It gives a definite advantage for that type of architecture.
Yeah. But we had a pro set on not too long ago, and exactly it. You know, setting these, you can set them straight when you do a top pick, versus wood construction where you got to do an angled set, right? So it makes a big difference. All right, let's see who else we have here. Joel Hutchins, lightweight concrete or GFRC?
It is regular weight concrete on this project due to it only being a 3-inch slab.
Right. Okay. All right, so George Ryman, love this. Thanks for sharing, very much appreciated. Andrew Seeley, brilliant work happening there and super cool. And then Craig Campbell says, hey, Dave. Hey, Craig, good to see you. So listen, everybody, we are live on 3 locations, but we're only doing questions on LinkedIn. It's the software. It's not the same stuff we have in our studio. So if you're on YouTube or Facebook, come over to LinkedIn and join the conversation, or we'll respond to you afterwards. All right, where are we off to?
Let's go out to our yard where we build outside if the building's too large to build it inside.
Yeah, absolutely. And tell you what, Bill, I mean, it's absolutely amazing. And I want to talk to you further, maybe at the end over here when we come back around, because we need more architects in this industry. We need more people that understand this space. And I think you could shine a little light on that.
Okay, my pleasure. I'll do that.
Good. All right, let's walk outside. All right. It's definitely busy beavers, and we actually have some people stop doing what they're doing a little bit, which is never good for production. Never. All right, so we're coming outside now, and you know, one of the things that I got to fix my mask here; it's falling down. One of the things, Casey, that you were telling me is that this isn't just a regular gravel parking lot that we're getting ready to walk through. This is an engineered parking lot.
Yeah, that is correct. So we had when NRB originally built this, when we were NRB, they had this engineered so we could build together outside as well, because we knew that there's only so much capacity inside our plant. Right. So we set up a temporary foundation out here, but we needed a certain thickness of gravel to be able to do that. So they took that into account when building this site.
Got it. Well, let's do this. Let's walk over. Dave, maybe you can just pan this way and show people the size of this lot. The project that we just saw is indoors because it's small. That project's small enough to be indoors. But we'll see as Dave pans around. We're going to walk over that way. That's the other half of this project, which is too big to be built indoors. Right. So we're building it here. And then we're going to wrap this all up on how it all gets taken apart and transported.
That's correct.
So, all right, David, let's walk over here. Let's talk about what we have set up. I see a ton of cribbing set up over here. Can you tell me, are these strategically laid out?
Yeah, so this cribbing set up exactly the way that the on-site foundation would be set up for the pier locations. That way the point loads stay the same throughout the whole entire process, on-site and off-site. So that helps with our precision, so that way the loads are transferring through the same spots at all, through the whole entire process.
So I'm just clear on it. So the cribbing is actually laid out in the same exact formation as what the foundation on site is going to be. All the point loads are exactly where they need to be. I see you even have steel plates on top of it.
That's correct.
Right, to get your leveling out, and that's where you'd actually make your steel weld connections to the foundation. So theoretically, you're doing a whole mock-up.
Yes, yeah, we are, and exactly, and we use those steel plates to level the building because, as you saw inside, that concrete pour has to be perfectly level, so it's one monolithic pour.
Right, which is really interesting. We'll talk a little bit more about that monolithic pour. Why don't we walk over here, David, where we were talking, so we can get this building in the background. That wind's picking up, so I apologize if people are hearing it in the mic. I did want to take you into the building here, but there's a lot going on, and I mean, you really got the crux of it on that building there as well. But what we will talk about here is the access, the trusses, the chases that are inside this building. So why don't we walk over here, and you can talk to me about what we have going on, because I'm seeing a bunch of angle iron laying around. I'm seeing a bunch of steel beams laying around here. You guys have a crane. I'm assuming that's almost permanently set up here at this point.
Yeah, so the crane it's here through the entire offsite erection process. It'll pull out and go to another project once the building's all fully erected. But while we're setting it, it'll stay here. And then once we get ready to de-erect, they'll come back in and lift these modules.
Got it. And what are the typical weights of these modules when they're finished?
So our typical weight of our module is about 75 pounds per square foot. So depending on the module size, it could be 40,000 or more pounds.
Yeah. Well, I know when we were at the hospital, said it was, I think, 40 to 70,000 pounds each module and what it was. So
correct.
Let's talk a little bit about what we have going on. If you want to come over here. Yeah. So all right. So here's a little bit different. We're starting to see some of the steel framing going up on this unit right here. So everything's put together. The fabricator did his job. It all came together beautifully, and it's snug. The concrete's all lined up. It's leveled out. Now these guys are actually in here starting to frame the walls.
Yeah, they are. So we're starting exterior wall framing. We're going to get this building completely dried in. Once it's dried in, that's when we'll start our MEP installation. So we're focusing on the exterior walls right now, and then we'll put on a roof, and it'll turn into a dried in building.
Right. And I think it's fabulous, because how easy is this to lay out all of your subcontractors in one spot? It's just a repetitive type step and repeat system for you by having a controlled environment like this.
Yeah, that is correct. And as you mentioned, we use all subcontractors, licensed subcontractors for all of our MEPs.
Right. So in this space, and Bill's over here. Bill, come here. Let me ask you a couple more questions, if you don't mind, as well. You were talking inside that you already pre-configured through the BIM program all the chases for the mechanicals and where everything needs to go. So, I mean, how does that work or translate with the trade contractor? How do they know exactly where everything goes? What documentation do they get?
Well, ultimately, in this particular project, we have a BIM coordination process where there's another subcontractor type firm that will provide the exact dimensions from finished floor to where the various pipes are, the ductwork, various electrical conduits, those type of things. So they're going to provide exact dimensions from finished floor to those components.
Right. And I know, Casey, you can come back over here in the picture too. So with this, tell me a little bit about your process with the trades. Is there a pre-construction meeting, sitting down in your office, going through every little detail with all the trades at one time?
Yeah, there is a pre-construction meeting. It's to go over their scope of work, to go over, where they're going to start and stop, what pieces are going to be left out for ship loose, for site install. And then, if it's a project like this, some of the trades might actually follow it to site and complete it on site.
Right. All right, so here's an interesting thing. So the trades come in, we know this building's coming apart, and with it coming apart, how much they're running the whole thing and then leaving space in between where the modules, because they know exactly where the seams are, correct?
Yeah, so they're going to run it straight through over top of the modular mate lines, and then they'll remove the pieces after testing, and then that'll be the ship loose piece.
Yeah, I think that's absolutely amazing, because one, you're putting it together. A lot of modular manufacturers aren't putting the project completely together on site. So you're going to have everything lined up exactly as it lined up here in the field, which reduces your time on site doing repair work or having to send repair crews out, right? I mean, it just comes together a lot better. I think it's absolutely amazing. What am I not asking you guys about this? Am I doing a pretty good job?
Yeah, so I will highlight one thing that's unique about this project. So you'll see in the middle of this building, there's an area that doesn't look like it has a roof section on the first floor. So this building is actually set up that there's only pan sections for the corridors. That was to allow for more space for the MEPs to run through the corridor sections. So it removed that. So it's not a full module there. It's just a floor pan and a roof pan.
Right. And there's an elevator in this building?
Yeah, there is. There's an opening right there. You can see through the roof.
Oh yeah, right up top here. So we're gonna get some B-roll of everything and some footage and walkthrough. So, but again, I mean, this is a job site. People are busy. So we're gonna share all that with you in the intros and outros that we'll put together for it. All right. So where are we heading now? Back into the production line.
Yeah.
Thanks, Bill.
As you can see coming through here, this is where all of our pre-cut steel comes in. It gets sorted out, labeled for which units it's going to be used for. So and then it goes into the production, into the jig. And they're all tagged based off of our structural shop drawings. So the guys in here know exactly where to use them at.
Got it. Love it, love it. So, hey, listen, if you're out there watching this, you know, we are live. Please like and share. And if you have any questions, we got the whole team here. You want to understand something, you want to know why it's better, we're going to talk a little bit about that when we get back inside. Hopefully the noise isn't too bad. But, you know, in the comments here, I'm trying to watch the best I can on my phone. Leave a comment, ask a question. More than happy to have these guys answer it for you. And I think there's a lot to learn here. I mean, we're only hitting the surface of it. So, all right. So when we talked earlier, when we started, this is all the raw steel in the field behind us, right?
That's correct.
Yeah. So this is the raw steel. It's already pre-cut from the steel fabricator. So you guys aren't doing that. You're just welding pieces together.
That is correct. We get it pre-cut based off of our shop drawings, which are produced from our Revit model.
Got it. Love it, love it. So, all right, let's walk back in here. So go ahead.
Speaking of welding, you know, all of our welders are certified welders. So Randy, you know, trains these welders, and we have an outside company come in and certify them.
Right. So Randy, and I'm gonna harp on this because I think it's super important. Let's walk over here so we get it in the background. That way we get the picture for you guys. What's super important about what we're doing here, what Randy and your team's doing is, and makes you different than everybody else, is your fabrication process to design the whole structure out of steel so that it can be put together and taken apart with the utmost accuracy.
That's correct. Yeah.
Yeah, and I think that's very important to point out to everybody here. This is where the time savings really comes in when you're putting this together and doing everything. Everything's in. Does it go together smoothly and quickly on site? What do you think is the most important factor of the line for you?
I think it's the precision. You know, the complexity of the projects that we can do and the precision. So the on-site completion's very minimal.
Yeah, for sure. Well, guys, I love it. I mean, so we're looking. I mean, this is a big structure and a big project. What is the timelines for this project?
It'll be complete and open for school in August of 2021. So there's a lot of on-site work, a lot of civil, and a big site portion to be built too. So we're going to beat that portion actually.
So you're going to get done with your work before the civil engineering and site work's done. Say that one more time. You're going to get done with your work before the whole site work done?
Before the site work and the conventional is done. That's correct.
I mean, so that's the speed, right?
Yep.
So this project on site, what are we looking for completion time once we set it on the foundation?
It'll probably be from the last mod set to completion. It'll probably be about 4 months.
I'm sorry, say one more time?
Probably about 4 months from last mod set to completion on site. A lot of that's due to, like, there's a full face block that goes on.
Right.
I'm fogging up, so
Yeah,
sorry
you're
about
fogging
that.
up. Yeah, it gets hot in here with these masks on. So 4 months for completion of this project once it's on site, where others would just start framing it or just start fabricating steel on site. And I don't mean to have my back to you. I apologize, Randy. I think that's where the savings is on this. There's less headache. There's less disruption on site. There's less disruption to a neighborhood, right, to a community that has to deal with this all the time. And this is really where the value comes in. And the other value is you guys know your costs. You may have some small site change orders, but that's a huge savings. And I don't think people realize that in their contingency budgets when they build this way.
Exactly. Cost certainty is one of the biggest drivers for modular, or should be one of the biggest drivers for modular.
That's exactly it, because big projects like this, they have contingency budgets in there. And I know on the last project and other ones, just from talking, they could be spending that money on something else, and that's what's going to happen.
That's correct, yeah.
Yeah. All right, well, let's walk in here. I want to show them one more thing, and go ahead, David. Just walk straight down. We'll walk behind you here, and watch you don't get run over by the steel guys. I mean, so you can show, David, if you want to show what he's doing, he's actually moving the steel from one location to another. All right, let's keep walking down. I wouldn't want to lift all that. It looks heavy, for sure. So, go ahead, David. And then we'll just stop right here at the computer. And I wanted to show them too as we get down here. What are we over here? We're going to show. It looks like a pod.
Yeah. So that is a government building. It's just a structure for a government project.
All right, so it's just an outdoor type structure that's going to be put in place for that building?
Right.
Okay.
Yeah, whatever's going in it will all be completed on site.
Perfect.
Yeah, so we do all different sorts of work, large buildings and small.
Yeah. Jim Gabriel's in the background here. John Buongiorno has been giving you a heck on the live feed here, but so come on in here, Jim. Definitely. This guy's awesome. Casey and Randy and all of them. John, Bill. They absolutely amazing crew you have here.
Yeah, I mean, this is what makes us unique. Not just what we build, but the team that we have that have more experience than probably anybody in this industry at what we do. That's how we can produce what we produce.
Yeah. And I don't think everybody knows, Jim, you've been in this industry like me quite a long time, so you really understand what's considered good.
Yeah, I say 25 and holding. It's probably closer to 30, but I like 25 plus.
Yeah. Well, I'm 25 negative, so I got you beat there. All right, so let's take a look. We have some other comments coming in here. I may have got to some of these already. Andrew Sealy, brilliant work happening there. Super cool facility. Craig Campbell. Thomas Coronado, very out there. I don't know what that means. Very cool out there. Joe Butler, thank you, MODLOGIQ, for the tour. Henry Mickelberg, all the way from France. Hey, Henry, is the school really close to your factory, or are you making stuff, inside, dry building it, factory, or are you making stuff inside, dry building it in your car park, then disassembling it?
I'm not so sure I understand that. It's not actually that close. How many miles?
It's about 2.5 hours away, so probably about 200 miles.
Yeah, but we are disassembling it, right? I mean, that's part of our process.
Yeah, for sure. So, Henry, so basically what they're doing is, they have their fabrication line where they're actually doing all the framing and doing the balloon structure, and then they're doing their traditional framing on site. Now, this is a commercial, structure made out of solid steel. It's a little bit different process than a wood structure, and Henry, I don't have to tell him that. He knows that loud and clear. So, but absolutely. And then, Casey was telling us, it takes this to about a 4-month process on site.
Yeah, this project is unique, and I'm sure you talked about it in terms of the sort of hybrid approach that a portion, 65,000 square foot, is being built in our facility here, but the total square footage of the project is about 95,000 square foot. Yeah. So, that's unique as well in terms of the combination of those two construction methods.
So what is the timeline on a project like this, from the time you actually get the go fabricating to the time you deliver it on site?
Casey probably knows a lot of the schedule.
So we started fabricating in the beginning of July, and the last module will ship at the end of March approximately, or set at the end of March.
It'll be set at the end of March, right? So you're going to start delivering these in January is what I heard. So, and you're still going to be done before the site work's done. Yeah. And I think that's the key here, because that's a time-consuming part. This is happening simultaneously. So now, and we were talking outside, Jim, the disruption is so much less for the community doing it this way than doing it on site, and that's a big point.
Yeah. And this new school is adjacent to another school, so site disruption's really huge to eliminate on this project. Even though it's COVID and maybe not all the kids are in, but there's still different school activities that could be disrupted.
Yeah. For sure. All right, let's take a look here.
What's our buddy John say?
Hold on a sec. Daniel Small, we'll get back to John. Daniel Small, what % of completion do they perform in the factory versus on-site finish work? Do they factory apply any exterior finishes, for example? Well, you know what, Dan? One of the things is, if you saw our MODLOGIQ Axis construction set, the hospital that you guys did in 11 and a half weeks, I'm going to make a parody of me saying that. 11 and a half weeks completion, seeing patients. You guys, I'm going to assume you guys are doing the exterior on this here. No?
So we are not doing the exterior on this, just because there's a site-built portion and it's a full block veneer on this. So it's too much weight to support for shipping.
Because they are full blocks. So what percentage of on-site work is it versus in the factory here?
So that's a unique part about what we do, which you witnessed for the Good Sam project. Our level of completeness is between 80 to 85% as an industry average, it's probably closer to 60%. Because of our build together process, mechanical, electrical, and plumbing is almost complete. It's complete, tested, and then we disassemble. So, and then with respect to the exterior, his question about exterior, we've done, we can apply various types of exteriors. What we're going to guide the architect or the owner toward is trying to achieve their goal aesthetically with a product that works with our production process. So, brick veneers. The Good Sam project had a split face block veneer. So yes, we're known for getting as much done in the factory as possible, but also being able to install that exterior finish on as well.
Perfect. Love it. Thank you for the answer. John Buongiorno, finally we get to see the handsome one. Thanks, John. I didn't think you thought of me like that. That's nice of you. Oh, you mean you? Oh, okay. All right. Brian White, impressive. All right, Caroline Albano, hey, good to see you. How many people work on a typical project within that timeline?
So, John, you want to come in and ask
John.
a question about how many people we've got on a typical project?
Well, hold on, before you do that, John, why don't you tell us a little bit about what you do here?
Hi, my name is John Harple. I'm the plant manager, so I oversee all the operations out in the shop. And that's also coordinating with Casey, the project managers, and all the sub-trades, and what needs to be done.
Oops, stay right here. Yeah, I'm just coming closer. I don't have to reach across Jim. Oh, he's trying to keep you in the middle. You go over there, Jim.
Got it.
So that's basically my scope of work.
Okay. So what are we looking at as far as how many people are working on this job in the factory?
The numbers could change depending on the trades and the scope of work. I mean, for example, Good Sam, we probably average 9 to 10 from each trade. On this one, it's going to be much more.
Yep.
And as things progress, you'll see more and more people come in just to meet our schedule and our shipping commitments.
Yeah, that's important to talk about because you're scaling, right? Good Sam project was around 7,000 square feet roughly. I mean, this is 7 times that, right? Or more. Yeah. So, and I think that's a big point to make. It takes a different level of commitment from people to get a bigger job done, right?
Yeah, and that's a good point about, the ability to be able to scale up, right? We've got a staff of welders and carpenters, on average between, 25 to 30 people, on staff here. Everyone else is a subcontractor, which allows us to scale up and be able to increase the speed around which we can deliver, our project.
Sure.
It's very, flexible in that way.
Right. All right, so here we've covered the whole gamut. We see all the pluses of what you guys are doing, and there's big pluses. The fact that you're going to get this whole building done, and I'm a believer now, in 4 months once it's on site, is absolutely amazing to me. What can we look forward to seeing from you here in the near future, Jim?
Well, we're taking on some we've got another project coming on after this. That's a design build project with one of our other clients, Whiting Turner. So it's a collaborative design build project, about 10,000 square feet. We also have another sort of a prototype or a large national retail company, and so it presents itself as the ability to be able to produce multiple versions of this, but we're perfect for the prototype. So we often will work with clients on the basis of the ability to be able to build, a specific, for a specific project, multiples, but you got to start somewhere. So our firm is perfect for that prototype. We can design it with our design firm. We can collaborate with their designers. We can then bring that project to life here in our plant, have them walk through it, understand how it's going to be built, and then we can go into a production run of 5 to 10 or more. So we've got some of those projects coming up too. Some data centers, equipment shelters. We're working on some products there to be able to produce some standard products, equipment type shelters and things like that. So we've got a ton. We've got a lot going on.
Yeah. So it doesn't sound like there's a shortage of work for you, which is great. We love a full pipeline in our industry, don't we?
Yeah, we do.
Yeah.
We do. That's
so
the key.
I love it. So Casey, what can we expect from you moving forward here? I mean, you got to spend a lot of time walking. He's a smart guy. I like this guy. Walking around and, I think it's really important if you kind of just elaborate one more time so everybody understands your role and what you're doing and how important it is, because I think, you know, we didn't touch enough on it in the beginning.
Yeah, so I'm the pre-construction manager here at MODLOGIQ. I work front end with the GCs, customers, and with the design teams to help the designers follow through to make, you know, a modular friendly building with Bill and our design team, as well as working out the scopes of work and the estimating side of the project to bring it in, you know, at budget for the client's budget. So scope of work's huge, as I discussed before. You don't want scope gaps or overlaps. So it's really important to have detailed scopes of work on a modular project due to the two site, you know, projects.
Yeah, no, I absolutely love it. And so, I mean, so if I translate that to everybody, I mean, you're a really important person because you're really kind of the liaison between a lot of people, making sure that all the details are where they need to be and everybody's pulling their weight. Is that an accurate statement?
That is correct.
Right. Well, I'd have you on my team in a heartbeat for sure, and that's kind of what you're getting here from MODLOGIQ, even with Jim Gabriel. I don't care what John says.
I knew it was coming.
So, all right, everybody, listen, please like and share this. And if you have projects and you really want to work with a great company, honestly, MODLOGIQ, I've been on a couple of your projects. I'm now getting to see the great staff, and you got to meet quite a few of them. But there's a whole other ton of people here that are working on behalf of customers that we don't get the opportunity to always have on, and hopefully we'll get some interviews with them before we get out of here to share that with you. But I highly recommend you guys. You guys are amazing what you're doing, and I hope I can see the school. I hope I can see the school come together. I'm coming down to watch the school come together.
Invited. You've just been invited.
I love it. So it's on camera. He invited me. All right, everybody. Listen, I'm Dave Cooper. We are live on 3 locations, LinkedIn, YouTube, and Facebook. I will look and see if there's any last comments, but I think that is, what kind of production tracking software system are they using? Sorry, we were going to end it, but...
like a production tracking software sales guy.
Yeah, who would that be? Production tracking software system. What do you guys use?
So we are actually looking to implement additional software right now. Currently, we track it just using like standard like Microsoft Project as a, you know, as our scheduling application. So that's what we currently use.
Got it. All right, and I won't get into John Borgiorno's stuff, but he said, all kidding aside, he gave you guys great reviews. John is the one that was running the Axis construction job with his team, Carolina and Johnny Rocco and all the other guys out there. They did a great job. So, all right, well, with that said, listen, everybody, if we missed any comments, we definitely will answer them. Buzz, thanks for joining us in the comments. So there you have it. We're at MODLOGIQ in New Holland, Pennsylvania. I'm Dave Cooper. We'll see you tomorrow at 1 o'clock. Thanks, everybody. Thanks, everybody that's behind the scenes there. You guys have a great day. David, take us away. See ya.